Stop asking, what's the best local AI model? And honestly, that's the wrong question. The question that decides what you can actually run at home is simpler than that. How much memory does your graphics card have? That one number picks your model for you. So by the end of this video, you'll know exactly which model to install based on what you already own. Whether you're on an RTX 4090, an old 3060, a MacBook, or even integrated graphics, I'll give you the model name, the honest caveats most coverage skips, and the exact command to get started. One more thing up front. Forget parameter counts for a minute. A compressed 27 billion parameter model can now fit into less memory than some 3 billion models from last year. That's how fast the floor has moved. So, find your number, look up how much VRAM your GPU has, and follow along to your hardware. We start at the very bottom, the tier almost all of you already own, 4 to 8 GB. Think a used gaming card, RTX 3050, GTX 1660, RTX 2060, RTX 4068 GB, AMD RX 7600, or you're on integrated graphics with enough shared memory, this is your bracket. And if you're thinking, I guess I settle for something dim, that's outdated. The best pick here is a 3 billion parameter model from a Chinese lab called Nanbeige. Their 4.2 release is tiny, but it does something its size should flatly not allow. Its trick is a looped transformer. Instead of stacking more layers, it runs the layers it has more than once. So, it thinks like a bigger model without storing a bigger model. You get the capacity, you skip the memory bill, and it lands. On agent tasks, coding, and reasoning, this 3 billion model beats Qwen 3.5 at 9 billion and Gemma 4 at 12. It is outscoring models 3 and 4 times its size. Look at coding specifically. On SettlW bench verified real GitHub issues fixed by an agent, it resolves 63%, roughly double what the same size Qwen manages. For a model this small, that number is a little indecent. And on GPQIA Diamond, a brutal graduate level science exam, it scores 87. That is a figure the flagship models were bragging about a year ago, now running in about 2 GB on your laptop. So, what is it for? Local grunt work. Tagging and sorting your files, classifying support tickets, labeling data, the high volume jobs where you want speed and privacy, not a giant brain that costs money every call. It is also a real assistant. Point it at a scaffold like OpenClaw, and it will handle multi-step office tasks and deep research fully offline, and it beats that 9 billion model at those two. It carries a 256,000 token context, so it can hold a whole code base or a stack of documents in its head at once, on 2 GB, no internet, no bill, and it out-reasons last year's mid-size models. That is the new floor. It only climbs from here. Second tier 8 to 24 GB if you own RTX 3060 12 GB, RTX 3070, RTX 4060 Ti, RTX 4070, AMD 7900 GRE, or a MacBook Pro with 16 GB unified memory. This is the most interesting bracket right now. Now we can get greedy, and this is where things get a little unreal. Normally, a 27 billion model is flatly out of reach here. In full precision, it needs about 54 GB. Even a careful 4-bit build is 18, too big for this card and nowhere near a phone. A startup called PrismML, a team out of Caltech, fixed that. They took Qwen's 27 billion model and crushed it down to almost nothing, and they call the result Bonsai. Here's the trick, and it is not normal quantization. They retrained every single weight to be one of 3 values, -1, 0, or +1, ternary. Under 2 bits per weight, top to bottom, no full precision escape hatch anywhere in the network. The payoff is absurd. The quality build is 5.9 GB. The tiny build is 3.9. A 27 billion parameter model that is smaller on disk than a full precision 2 billion model. And that 3.9 GB version fits on an iPhone, an actual phone. It is the first 27B class model to run on the device in your pocket. Reasoning, tool calls, even reading images. Your gut says they must have crushed the brains out of it. They mostly did not. The ternary build keeps 95% of the original score. The 1-bit phone build keeps 90. Math and coding barely move at all. And here's the part that makes it more than a party trick. Take the most aggressive normal 4-bit build of this same model. Bonsai's 1-bit version scores higher than it while using 2 1/2 times less memory. It is a strictly better trade than the quantization everyone already trusts. It is not slow either. On an RTX 5090, it runs at over 160 tokens a second. On a MacBook's M5 chip, still fast enough to feel instant. This is a usable daily driver, not a lab demo. And it is free and painless to grab, Apache 2 licensed, running natively through MLX on any modern Mac and CUDA on Nvidia cards with a full 262,000 token context. Download it, point ollama at it, done. PrismML calls this intelligence density, and I think it is the real story of the year. A model this smart used to demand a real GPU. Now it lives on your everyday card with room to spare, and every step it runs costs you exactly nothing. Third tier, 24 to 96 GB. Now you have real room, a 32 gig 5090, a pair of cards, or a Mac with a big pool of unified memory. So here you stop compressing and just run the good model at full quality. And the good model is the one Bonsai was carved from in the first place. Qwen 3.627 billion dense. Qwen calls it flagship level coding in a small model, and the scores back the brag. It posts 87.8 on GPQA Diamond and trades blows with models several times its size. At full precision, it wants about 54 GB, which finally fits here with headroom for a long context. But there is a hidden tax on these reasoning models, and if you run them locally, you feel it in your bones. They think out loud before answering, sometimes for thousands of tokens, and every one of those tokens is time you sit there and wait. So a small European team called BottleCap AI shipped a fine-tune to fix exactly that, and the co-founder is not a random name. It is Tomasz Mikolov, the researcher who invented Word2Vec. They call it Thinking Cap. Same model, same answers, but it learned to stop overthinking. About half the reasoning tokens on average for the same quality output, and on some prompts, it wraps up as much as 10 times faster. I want to be precise here, because the internet garbled this one. The model is no smarter. It reaches the same score with far less rambling, which, when you are the one waiting on it, is the upgrade you actually feel. So on this rung, the move is a pair, run Qwen 3.6 at full quality, drop the Thinking Cat fine-tune on top, and you get flagship coding that answers in roughly half the time. Who is this bracket for? The person who codes against a local model all day and is tired of watching it think. Same brains as the cloud sitting on your desk now without the long, awkward pause before every single answer. Fourth tier, and now we leave gaming cards behind entirely, 96 to 192 GB. This is workstation territory, and it is defined by one specific little box that rewrote the math for the whole tier, Nvidia's DGX Spark, a 1.2 kilograms box that sits under your monitor with 128 GB of unified memory for around $4,000. It holds models a $4,000 graphics card cannot even load, and the model built for exactly this box landed on July 21st. Laguna S2.1 from a San Francisco startup called Poolside, an open-weight coding model, and a genuinely surprising one. It is 118 billion parameters, but only 8 are active at any one time. That is a mixture of experts. Most of the model sits dormant on each token, and that sparsity is exactly why it drops onto a single spark and still runs fast. Here is the surprise. On Terminal Bench, a long horizon coding test where an agent drives a real terminal, Laguna scores 70% and beats DeepSeek's flagship at 1.6 trillion parameters. It is beating a model roughly 14 times its size. Poolside is calling it the West's most capable open-weight model, and on its size class, the claim mostly holds up. 40% on DeepSeek, a harder test where trillion-parameter open models routinely score under 10, and it is not just a number on a chart. In one unbroken 50-minute run, no human help, Laguna built a working browser engine from an empty folder, then proved it works by rendering pages against real Chromium and comparing pixel for pixel. It is not flawless, and Poolside says so out loud. It can overthink a simple task for ages, and it sometimes fumbles an unfamiliar tool format. But an open model that argues with itself until the test actually passes is a genuinely new kind of thing to own. It ships with up to 1 million tokens of context and an open license, and it went from the first day of training to launch in under 9 weeks. That release cadence is its own kind of warning shot, and getting it is easy. The weights are on Hugging Face from day one, and VLLM, SGLang, and Ollama all run it locally out of the box. Nvidia even tuned it to serve on a single spark. This is built to be used, not admired. Frontier-grade agentic coding, the kind that was locked inside a cloud API 6 months ago, now running on a box that fits in your backpack. Top rung, 192 to 384 GB. 2 of those Sparks lashed together, or a proper server. Very few people are up here, but if you are, the reward is the best open model on Earth that is not from America or China. It is called Motif 3, and it comes from a Korean startup, Motif Technologies. 314 billion parameters, a mixture of experts, and this is the part 1 respect built from scratch, not a fine-tune of somebody else's model. Under the hood, it is a sparse design. 384 expert networks, and only a handful fire on any given token, so about 13 billion parameters are doing the work at a time. Big brain, cheap to run. And here's where it sits. On artificial analysis, the industry's main intelligence ranking, Motif 3 is the 3rd best open weight model in the entire world. Only Kimi K3 and GLM 5.2 are ahead of it. If artificial analysis is new to you, it is the closest thing this field has to a neutral scoreboard. One index that folds a batch of hard reasoning and a genetic test into a single number. 3rd place on it as a model you can host yourself is a very big deal, and sit with the company it is keeping. The 2 models above it are Chinese giants. Kimi K3 alone is 2.8 trillion parameters. Moe is a fraction of that size from a firm most people have never heard of, and it is right on their heels. 314 billion is a lot, but sparse and quantized to 8-bit, it lands around 300 GB, and less if you push the quantization, squarely inside a 2-spark or a single server budget. Why does a top 3 open model matter to you specifically? Because open weight means you can download it, run it behind your own walls, and nobody can rate limit you, price hike you, or take it away in a product update. That is the whole ladder. 5 brackets, 5 models, and every one of them ran on hardware you can sit on a desk. So let's line them up one more time. 4 to 8 gigs, Nanbeige. 8 to 24, Bonsai. 24 to 96, Qwen with a thinking cap. 96 to 192, Laguna on a Spark. And above that, Moe. Now, the honest catch, because I'm not going to oversell it, none of these are GPT 5.6 or Claude Fable. The closed frontier still sits around 90 on these coding tests, and local still trails it. This is the best you can own, not the best that exists. So how do you choose? Simplest rule I can give you, find the biggest model that fits your memory with a little room left over for context, and run that one. When it fits, bigger still wins. It is almost that boring, but the real headline is not any single model on this list. It is that the one that fits your box today is dramatically better than the one that fit it 6 months ago. The floor is rising, and it is rising fast. And if you have never done this, do not overthink it. Ollama is 1 install and 1 command, ollama run, then the model name. LM Studio is the same idea with a friendly window and a download button. You are about 10 minutes from a private model, not a weekend, because every model here is a free download on Hugging Face. Pull the one for your bracket, load it up tonight, and go find out what your own hardware can actually do. I really think it is going to surprise you. If this saved you a week of trial and error, subscribe. I break down the local AI stack here every week. I will see you on the next.